We'll go ahead and get started today. Thank you all for joining us today. My name is Megan Balding, and I'm with the USC Viterbi School of Engineering. And it is my pleasure to welcome you to today's session of our Spotlight series, where we highlight our master's degree program in astronautical engineering. We're joined today by Professor Mike Gruntman, who will be sharing information on the degree program and answering all of your questions during the session today. Before we get started, I wanted to just mention that we will be sending out a copy of today's slides. So I know we include a lot of really great information for all of you to reference. You can reference those at a later point in time. It does take us about 1 to 2 business days to get that email out to you, but we will get that out to you as soon as we can. Now, in terms of asking questions, I highly encourage you to ask questions during today's information session. We'll be leaving some time to get the Q&A at the end of the session for question and answer. So if you want to go ahead and use the Q&A panel, that will allow us to best monitor any questions coming in. So if you can avoid the chat window and go ahead and use that Q&A panel to ask any questions that you have, it enables us to make sure we are responding to anything that comes through. Now, in terms of today's program, I'll be providing a quick introduction to the University of Southern California and the USC Viterbi School of Engineering. I'll then briefly touch on our Dennett Viterbi online delivery option, as well as an overview of tuition and fees. At that point, I'll be passing the presentation over to Professor Gruntman, who will be specifically addressing our astronautical engineering program at the master's level. He'll be giving a department and program overview and a description of our application criteria. Upon completion of that section of the program, we will then go into the Q&A. If you've never visited the University of Southern California, we've included some images here of USC. You can see here we are located in a very sunny Southern California near Los Angeles. Obviously, some of these pictures were taken pre-pandemic, so excuse the gathering of our football players there. But what I really wanted to just quickly touch base on in terms of USC is that we are the oldest private university in the Western United States, founded in 1880. We have about 46,000 students, about 19,500 undergraduate students, and just about 26,500 graduate students. We currently have just over 4,700 full-time faculty members within the university, and a diverse student population with students coming from all 50 states and over 100 countries. We are, as I mentioned earlier, located in Los Angeles. We're just south of the downtown LA area. Now, in terms of the Viterbi School of Engineering, we have 8 academic departments. Today's presentation will be focusing on the Department of Astronautical Engineering within the USC Viterbi School of Engineering. We have 189 tenure track faculty throughout the Viterbi School, of whom 17 of our full-time faculty members are members of the National Academy of Engineering. We have over 90 National Science Foundation Career, National, and Presidential Young Investigator Award winners. Our student population consists of about 2,800 undergraduate students and around 5,500 graduate students. Graduate students consist of our master's and doctoral students. Our master's students include our on-campus master's students and our online master's students. And we'll get into all of that in just a few minutes and talk about your options that are available to you. In terms of research, there is so much exciting research going on within the Viterbi School and just not enough time to talk about it in any one setting. So I do encourage you to visit viterbischool.usc.edu to explore our research centers. We have over 35 research centers and over $212 million in research expenditures annually. We are consistently a top-ranked graduate engineering program by U.S. News and World Report. In terms of our online graduate engineering program, we are currently the #2 ranked online graduate computer information technology program for our computer science program. And we're ranked #5 overall for all of our online graduate engineering programs, including our MS in astronautical engineering. We also have similar rankings for those online programs as they relate to the rankings for veterans as well. In terms of our USC Viterbi points of distinction, we have a strong international reputation for excellence. A lot of that has to do with our amazing network of engineering alumni. We have over 80,000 engineering alumni located throughout the world. Within the Viterbi School of Engineering, we offer programs online, on-site, and on campus. Our on-site programs are specifically related to our continuing education offerings, where we can offer continuing education programs on-site at an organization based on your the training needs of that group or department within an organization. We offer a complete range of educational programs, including our PhD, master's, and bachelor's degrees. We do offer graduate certificates as well, and we'll be getting into that today and providing some general information on our graduate certificate in astronautical engineering as well today. I already saw a question pop up about that in the Q&A, so we'll make sure to talk about that during today's presentation. As I mentioned, we also offer continuing education courses, which are short courses, around 2 to 3 days, up to 15 days potentially, based on your area of interest. Now, within the Viterbi School of Engineering, we are considered a leader in funded research in the United States. I've listed a couple of our research centers, one of which I wanted to specifically mention, our Space Engineering Research Center, or CERC, which is located in Marina del Rey. We have a highly interdisciplinary research environment with diverse research areas across many fields. We've listed some of those here. But again, I do encourage you to visit our website to find out more information on all 35 research centers, including the industrial partnerships and collaborations that go on within those centers on a daily basis. Now, I wanted to just quickly touch base on 2 of the delivery methods that are available to you as you consider pursuing a graduate program at the USC Viterbi School of Engineering. We have our on-campus delivery, which tends to be our full-time student program. So our traditional students that come to campus, obviously in normal times, things are a little bit different these days, but we do hope to get back to our regular delivery options shortly or as soon as we are able. Our on-campus students tend to take around 3 to 4 classes in a semester and take about 1.5 to 2 years to complete. Now, one of the things I'll mention here is this is some general information across all of our master's and graduate programs. Professor Grutman will be speaking directly about the MS in astronautical engineering students in just a few minutes. The other delivery option we have is our online delivery via Dennett Viterbi. Dennett Viterbi is the online delivery method within the Viterbi School. This is generally utilized by working professionals, but you can be a full-time online student if you'd like, based on your individual needs. But generally, our students pursuing the program online are working full-time, taking around 1 to 2 classes per semester. On average, they're completing their degree in 2.5 to 3 years because they are taking, classes fall, spring, and summer. But that can range, and we have students completing the degree in all manners of time based on their needs and their specific timelines. Now, in terms of the Dennett Viterbi delivery, the Viterbi School of Engineering utilizes a state-of-the-art proprietary web-based delivery system that enables students around the world to access classes live and on demand. So what does that mean? It means that our Dennett Viterbi students are viewing the same lectures as their on-campus counterparts with fresh content every semester. So when you register in a class that you're taking as a Dennett Viterbi student, you're taking that class, you're participating in and enrolled in a class that's happening, again, in normal times on USC's campus. You have the same faculty member, you're following the same syllabus. It's a completely integrated delivery. The benefit of it is that it does provide you with the ability to view the lectures, the recorded lectures in the evenings or on the weekends if you're unable to attend the live class, which is a great option for working professionals. But you are on the same calendars, your on-campus counterparts, you're following the same syllabus, you have the same homework deadlines, and the same exam schedule. So exams are done at proctored locations in your area. If you live in the greater LA area, you'll come to USC to take your exams. Otherwise, you work with our exam proctor to complete your exams at a location near you. The following is a quick overview of the similarities and some of the differences between our online and on-campus students. One of the main things I want to point out here, though, is the program admission requirements are exactly the same, regardless of whether you're pursuing the program online or on campus. So when we go over the application requirements for the MS in astronautical engineering today, there is no difference in the process, whether you are applying to or intending to pursue the program on USC's campus or online. The process is going to be the same for you. Where the difference comes in is once you enroll in your class, how you enroll, and how you have that course delivered to you, whether it's you're sitting in a lecture on or a lecture hall on USC's campus or in a classroom on USC's campus, or you're participating as an online student via Dennet Viterbi. I've mentioned a number of these items, but again, you're following the same syllabus, same calendar as your on-campus counterparts. Degree completion requirements are going to be the same. You are going to be required to complete the same number of units, the same requirements, regardless of whether you pursue the program online or on campus. And ultimately, the diploma you receive is going to be exactly the same. You will receive your USC diploma from the degree program that you graduate from. It does not indicate online on that degree or on your transcripts. This is a quick snapshot of one of our Dennet Viterbi classrooms. So something you'll see once again when we return to normal operating procedure back on campus. We do have our Dennet Viterbi classroom set up with a camera operator in the back of every classroom, a live individual that's making sure to capture everything that's happening within that classroom setting. The following is a snapshot of your archived lecture video, so you can see what the lecture will look like if you are viewing the recorded archive of that lecture for the day. The following as well is one of our faculty members who is utilizing the smartboard in their classroom, where you're able to, as a Dennet Viterbi student, capture everything that's happening within that classroom clearly, able to see the notes that are being taken within the classroom and make sure to capture everything yourself that's happening within that lecture that day. All right, just a couple other quick things I want to mention, and then I'll be passing the presentation over to Professor Gruntman. If you are interested in the Dennet Viterbi option, there is a delivery called limited status enrollment that it allows qualified candidates to begin coursework before formal admission. If you are interested in this option for the MS or for the astronautical engineering area, I do want to mention that you, in addition to the standard requirements, you must also have the required coursework in physics as well. Your courses that you can take as a limited status student are a maximum of 12 units, so around 3 to 4 courses that can be applied toward a degree program once you apply and are admitted formally to that degree. Starting classes as a limited status student is basically a way to jumpstart your coursework. You can start as early as this summer, this upcoming summer term, but ultimately you will want to go through that formal application process and receive your formal admission to your degree program. To get started with limited status, you can visit the link we've provided here. Additionally, we do have the option for the tuition deferment program. Tuition deferment allows those of you that are receiving tuition assistance organization to defer the upfront payment of tuition, up to 90% of that, until after the semester is over. So it's a great benefit for those of you that are receiving tuition assistance from your organization. The following is an overview of the tuition and fee structure for the fall 2020 to summer 2021 academic year. The current cost per unit is $2,148. Therefore, a 3-unit course comes out to about $6,444. To review the additional fee structure, we've provided a link here so you can see what fees would be applicable to you. All right, so the application deadlines. These are the general application deadlines for our graduate program. I will mention that Professor Gruntman will be going over the department-specific deadlines for astronautical engineering in a few slides. But ultimately, one of the things I just want to mention is that there is still time to apply. So if you are interested in applying for fall 2021, you are able to still apply for the MS in astronautical engineering. Now, Dennet Viterbi students are eligible for an application deadline extension. So if you are interested in applying as a DEN student, you can go ahead and email our team and we'll connect with you about when that application deadline is for you. On-campus students, you can go ahead and email us as well, and we can work with you on the upcoming application deadlines. Now, for spring 2022, the deadline here for our general program is September 15th. If you're an on-campus student, you can apply for the scholarship consideration deadline, which is August 31st, and you will be considered for a scholarship consideration. All right, so these are just some quick links to get started. We again will be sending out these this presentation to you following the session, so you can access these links to the application. You can take a virtual tour of the campus and get started through these links provided. All right, without further ado, I would like to introduce Professor Gruntman. Professor Gruntman is our department chair for the Department of Astronautical Engineering. He's our program director for the MS in Astronautical Engineering as well. And of course, is a professor within our Astronautical Engineering department. His research in astronautics, spacecraft and space mission design, space physics, space instrumentation and sensors, space plasmas, spacecraft technologies, rocketry, propulsion, and orbital debris. He's authored or co-authored, more than 300 scholarly publications, including 4 books. So it is my pleasure to introduce Professor Gruntman, and we'll pass over the presentation at this time so he can share information on our MS in astronautical engineering.
Thank you, Megan. Is my sound okay? Can you hear me? Excellent. So first of all, just a tiny correction. I escaped being department chair recently, so I'm not anymore, and I'm so happy. But this is something that we faculty do, and I actually served as the founding chairman. It was 15 years ago of the department. So this is what we do. Is a part of service, but I continuously direct our master's program for the last 25 years. So I'm the right person for that. I also want just to mention, Megan said a little bit earlier that among our requirements are physics courses. These are not something special or additional. These are standard physics, undergraduate physics courses that engineering students take. The issue is that in some programs like applied mathematics, for example, and computer science, sometimes they don't take regular physics courses that all other engineering majors are exposed to, and then this becomes deficiency that needs to be addressed before enrolling to the program. But we know how to deal with that. Just contact us directly and we will advise and guide you through this process. We have such students all the time. So let's go to the next slide, please. All right, so we will very briefly go through the Department of Astronautical Engineering. This is a unique department in the country because typically space engineering is a part of aerospace departments or aerospace programs, which combine space and aeronautics or airplanes, if I use a loose term. So we're a unique department in the country that's purely space engineering focused. We will talk about faculty, research areas, and then we'll zoom in onto Master of Science in Astronautical Engineering. We'll talk about students, coursework, and the criteria for applications. So here we also have my contact information, my email, and you can find it also obviously on the web. And in addition, I want to point out there's a link to a PDF file. You can download 3 publications describing various aspects of our programs, about the department, how it was built. It's one file that describes the focus, the structure of the programs and all that. A lot of useful information. So you may want to take a look if you are interested. A lot of details are there. Next, please. So we were established formally in 2004, 15 years ago, but we built upon specialization, space engineering or astronautical engineering specialization that existed since mid-1990s. We expanded and then we became an independent department. As I mentioned, I served the founding chairman, and then served recently again a chairman again, and now unfortunately not in this position. So we established the full scale of programs. We have an undergraduate program, as any academic department in any leading research university in the United States. We have a Bachelor of Science program, Master of Science, PhD, graduate certificate, and we are doing all the usual things that departments are doing. And on the left is a photo of Neil Armstrong. Some of you may know that he actually got a degree degree from the USC School of Engineering. So this is one of our most famous alumnus. Next, please. All right, so as I said, we have all degrees we offer all degrees, all levels of the degrees in astronautical engineering. Our mission is to provide forefront research and education in space engineering. Our main customer is the space industry and government space research and development centers. That means NASA, armed services like the Air Force, the Space Force now. There's some other government agencies that have space programs, and industry. And industry is becoming more and more important as the commercial industry is actually expanded dramatically during the last several years, and there are a lot of new applications are coming. Our Master of Science program is very prominent, one of the largest in the country in this field. The next slide, please. The department is relatively small in terms of full-time tenured faculty. So the list is shown here on the left. But what is important for our master's program is that we rely primarily on talent in the industry to teach specialized courses. And again, this is not an undergraduate program. This is the master's program that we are talking about, and a lot of specialized courses, a lot of areas of interest, of importance, of current interest, of current development in space industry and government centers. They are not part of the traditional university environment or traditional interest of university faculty. So we rely upon the best talent that we can find in Los Angeles, and we are in the right place. A significant part of the American space enterprise is in Los Angeles. So on the right is a list of almost 2 dozens. We have part-time lecturers, instructors, adjunct faculty who are hailing from the local companies and the government centers. You see a large number of our instructors are coming from the NASA's Jet Propulsion Laboratory, from the Aerospace Corporation, which is the Air Force's main center, and a number of industrial companies such as Raytheon and the Microcosm and the Space Environment and the Lockheed Martin and Aerojet General. Next slide, please. So our faculty of our department in our adjunct faculty, we all do what faculty does in every leading research university. We teach, we do research, funded primarily by the government agencies and by the industry. Faculty publishes articles in the journals, presents results at the conferences of the professional societies, and publishes books. So some of the book publications of our faculty and instructors is on this slide. So we again do as all faculty in the leading research university do. The next slide, please. Research areas that we are cover is various fields that are part of astronautical engineering. So it's a space environment, spacecraft interaction, space science, instrumentation, the propulsion, rocketry, space mission and spacecraft design. Human space flight is growing in importance, and later we'll talk a little bit more about some growing areas. And our faculty is active researchers. They have a very good record. They were parts of a number of the missions, space missions by NASA, other government agencies, part of the industrial projects. We also have student groups that are very actively working. One of them is the so-called Rocket Propulsion Lab. It's primarily undergraduate students. They're building solid rockets, and last year, 2 years ago, they broke a world record. They're the first group in the world that reached 100 kilometers. This is so-called von Karman line, so they reached space. Liquid Propulsion Laboratory concentrates on building liquid rocket engines. And again, a lot of our Master of Science students are part of this group. And there are also groups in the Space Engineering Research Center affiliated with our department, part of the Information Sciences Institute that Megan mentioned earlier in the presentation. So this is also our a group where a lot of different activities take place, CubeSats and other projects. The next slide, please. So we have obviously collaborations with other groups and departments inside the universities and outside. We interact with all the engineering departments within the school. It's a very good environment, very good community of researchers and educators to interact with. Also, we interacting with the physics and astronomy department in the college, and we have a very extensive external collaborations. Our faculty works with colleagues and peers in other universities like Harvard, Berkeley, Arizona, BU, and NASA centers, JPL, Goddard, Department of Energy, national laboratories such as Los Alamos, and many, many other leading government centers and industrial companies, as well as foreign countries such as Poland, Japan, Germany, so you name it, just in many other countries. The next slide, please. So now let's talk about the Master of Science program. So we a degree in a highly dynamic area and technologically advanced. And you know that the landscape there is changing. You hear the news all the time about proposals and work on huge constellations of satellites and various applications. Now, the degree is specifically does not require the background in aerospace engineering, and this is a difference from many other degrees in the space area, space engineering area, where in order to get a master's degree, one has to have a degree in our Bachelor of Science degree in aerospace engineering. We are specifically designed in such a way that we are open for students with all backgrounds in hard sciences and engineering. The only exception, as I mentioned, is if you didn't have a regular physics classes required for engineering students, such as in the computer science occasionally and applied mathematics or mathematics, then you will need to take these classes in the community college. And after that, you are very welcome in the program. And again, we're taking it from here. Now, why we do not require aerospace background. Space industry is populated by engineers with all different flavors. They're coming from the chemical engineering, electrical engineering, computer engineering, aerospace, mechanical, physics, astronomy, chemistry, from very different areas. And in order to grow in the industry through the ranks and to the leading technical leading positions, one need Master of Science degree with focus on space, but they cannot get into normal programs because they would require Bachelor of Science in Aerospace Engineering. And so here we step in, we provide a Master of Science degree in Astronautical Engineering if you're coming from the background outside of aerospace or space. I don't have the exact statistics, but roughly I would say more than 1/3 of our students, graduate students in the master's program, have undergraduate degrees other than space related, other than aerospace. So it's again, we're specifically open to such students. Our regular tenured faculty teaches a few fundamental courses, but most of the highly specialized courses on the cutting edge, on the current practices in industry and engineering are taught by the leading experts from the industrial companies and government research and development centers. The next slide, please. So our students are basically from two categories, from full-time on-campus students, they're close to 1/2 these days, and distance students or online students studying part-time, another half. We have also students who are on active military duty many of them officers, and just looking what to do next after they will leave the armed forces, and also those who serve and want just to get advancement in their careers. So we have, as I said, students with different backgrounds: astronautical engineering, mechanical, electrical, aerospace, chemical, computers, physics, astronomy, and others. And so this is, we have a very diverse student population. We even have every, say, other year, we have a new student coming with a medical degree, and they usually want to get into the astronaut corps. And this is another feature that we have always, every year, a couple students entering the program who specifically choose us because they think that it will be helpful for them to get selected for astronaut training. The next slide, please. So it's a little bit of statistics. We are growing, and as you see, the number of the degrees that we award every year. Today we are above 50 or around 50 per year, and half of them are on campus blue, the students that are full-time students, and the yellow parts of the bars is those who get degrees online. So it's a close to 50-50 these days. Now we are growing. So what does it mean? That means that we're in a very competitive environment, and the program that we offer has some real value. And I'm just emphasizing that because half of our students, they are from industry and the government centers. And if you work in a company such as Boeing, Lockheed Martin, Northrop Grumman, or JPL, you could choose basically any graduate program in the country you want for your Master of Science degree. And if the students coming to us, that means that we offer something of real value. And because we are growing, continuously growing, as you see from the chart on the right. So this is an indication that we provide something of practical value of practicing engineers. And obviously students that come full-time to study to us on campus, they also reflect that perception. So the program is very large. We approximately 3% or 3.5% of the national number of Master of Science students that get degrees, about 3 or 3.5% out of the aerospace students. National statistics doesn't separate space engineering from aeronautical or aerospace. In this large combined area, we're about 3 to 3.5%. And in the country, we have approximately 65, 70 aerospace programs. So we are twice as large as an average aerospace program in the country, and space is usually a smaller part of the aerospace department. So it's, again, we're very large in the country. So after the department was formally established in 2004, we awarded close to 700 degrees now. The next slide, please. So we also have a community of our alumni that's already, again, it's 600-700 students on the LinkedIn. Next slide, please. So admission and the coursework. As we already emphasized, one doesn't have to have a degree in aerospace engineering or space related. Any Bachelor of Science degree in engineering and in hard sciences, and we will take you from there. So we require grade point average at least 3.0 as the School of Engineering. This is the bar. And the GRE is required. This year was special because of the pandemic. It was suspended temporarily. So we will see how it will play out in the future. And we require 2 letters of recommendation. Now, in order to get a degree, yes.
I apologize. I don't mean to interrupt. I do want to just touch on the GRE just as a reference point.
Please.
So for those applying for fall 2021, the GRE has been waived due to the current circumstances with the pandemic. If you are looking to apply for a future term, including spring 2022 and beyond, please note that you should contact our office once the application becomes available for that term to confirm whether the GRE will be required. So the GRE waiver is currently only available for the fall 2021 term. Beyond that, you should contact our office to confirm the requirement.
Thank you. It's a very good point. So it says, as I said, we do not know yet when and how it will go back to the pre-pandemic level, but we'll see how it's going. I also want to mention that the admission to the program is done based on the totality of the record. And there are cases when somebody didn't really do well during undergraduate years and pursued some other things, playing certain sports and marching in the marching bands and doing some other wonderful things, and the GPA suffered and doesn't qualify. So however, the person then goes to work for an industry and really shows now passion and just works and develops professionally. And we look at the totality of the record, and if there's for example, very excellent GRE scores and excellent letters of recommendation, but GPA still just say below 3.0, we may admit such a student on a conditional basis. There's a special pass for students that we believe will successfully complete the program. So if you admit it conditionally, then the condition is that the typically first 3 or 4 courses at USC, you should show that you really would be successful. That means that you will get a B average, so basically B or higher your average, and after that you are automatically converted into a regular student, and what all courses that you took in this conditional status will be applied towards your degree. So it's again, if you can demonstrate that you will be a successful student by, say, your performance at your work or by some other ways. So there's a still possibility to be considered for admission to the program. In order to achieve the degree, we require 9 courses, and each course in our program is 3 units. In some departments at USC, there is a transition to 4-unit courses. In astronautical engineering, for foreseeable future, we will stay with this mode of operation that will have 3-unit courses. So you need to take 9 courses or 27 units. 4 courses are required in the spacecraft system designs. It's basically an overview of the space systems that we are working on, space environment and spacecraft interactions, spacecraft propulsion, and orbital mechanics. Then there are 3 core elective courses. These are the courses from a list of astronautics courses that we offer. And then 2 other courses are technical elective courses that in principle can come from any other department in engineering or perhaps in science. We usually approve practically all courses that students want to take, but most of our graduate students choose these 2 technical electives from the list of our core electives, because the reason that they're coming to our program because of the unmatched choice of highly specialized courses in space engineering. I also want to mention that if during undergraduate years you took a senior level course, for example, in spacecraft design or propulsion or orbital mechanics, then we evaluate your record, and if what you took, the content overlaps significantly with our required courses, we will waive this requirement. We don't want you to waste the time and go through the course again that you already took during your upper level undergraduate studies. And if this happens, it does not reduce the number of units that you need to need accumulate towards your degree, but it will open you a possibility for another technical elective course in a space area. And if you are interested in master thesis, it is optional. It is not required. And typically we have 1 or 2 or 3 students every year that pursue that. And one of the reasons that very few students are doing that first of all, they come to our program because, again, of this unmatched selection of courses in various areas of space engineering. They want to take rather coursework rather to do a thesis. And also the credit that you got for thesis in terms of units is relatively small, and it's much easier to take coursework than to do thesis and provide a 100-page document. But again, it's open for those who want to do, and we have every year a few students pursuing that. The next slide, please. This is astronautics coursework. So I color coded them in the different areas. So if we start from the top left, it's the system type courses touching on various aspects of space systems. Then there is an astrodynamics or orbital mechanics courses. I also include attitude dynamics and control, a cluster of courses. Then there are courses that are clustering around the spacecraft propulsion or rocket propulsion area, in spacecraft propulsion, liquid rocket propulsion, solid propulsion, advanced electric propulsion, space launch vehicle designs, and others. Then there's green courses. It's a structural dynamics. Then there is a courses in this brownish color on various subsystems of satellites like spacecraft sensors, remote sensing, and the thermal control. And we have two areas of coursework that were growing recently. One in space safety, and this is a unique place in the country. We are pursuing rather aggressively to develop a cluster of courses in space safety. This will be a very big area in the future. It's also, it already grows rapidly, and the reason is that these huge constellations that various commercial companies want to launch, and also forthcoming space tourism and the flying of astronauts or tourist astronauts, either suborbital or to low Earth orbit. So this would bring a lot of safety considerations. So this is a very rapidly growing area, a multidisciplinary area in space engineering, so we grow that. And also we established a cluster of courses now in the human space flight, and we are benefiting that a former astronaut, Professor Riesman, joined our program. He's a faculty member, full-time faculty member, so he's building up a cluster of courses in this area. We have a unique perspective and exceptionally qualified faculty that are guiding the development of coursework in that area. So it's, again, these are the courses. It's as I mentioned, it's an unmatched collection of courses in various areas of space engineering. Next slide, please. Criteria for applicants. So as I would repeat again, it's a Bachelor of Science degree in engineering or science. No need for aerospace degree, Bachelor of Science degree, GPA, GRE. Today we don't need it for the application for fall semester of 2021, but after that, it's TBD, to be determined. 2 letters of recommendation. And the deadlines, this is something that you always just checked with the department. We have an excellent student services, or through Megan and her office. They will always guide you to the right people that we would advise you on the exact deadlines. So what are shown here is this is standard deadlines. Next slide, please. And finally, common questions to anticipating something that you may want to ask. So as Megan said, the full-time students, they typically take 3 courses per semester. So that means well, it takes 3 semesters, 1.5 years to get a degree. However, a number of our students, full-time students, actively seek internships or part-time work in the local space industry and government centers. And when it happens, sometimes they like it there so much and they become so valued and overloaded. So they have to increase the number of hours that they spend there, and they reduce the course load. So then the achievement of the degree may just delay a little bit. And among the companies, we have, again, companies in Los Angeles local. It's Northrop Grumman, Boeing, the Aerospace Corporation, Government Center, JPL, and SpaceX was hiring a very large number of our grads, and also for part-time. If you have part-time students, it's typically 1 or 2 courses per semester, as Megan said. And so it takes typically 4 years to achieve the degree. Now, the course sequence, do you have to take required courses before electives? The answer is no. The course sequence as you take them is entirely up to students. There's a few exceptions. For example, if you want to take a course in liquid propulsion or in solid propulsion, you have to have a course in spacecraft propulsion, the first course, introductory course. And orbital mechanics 2 requires orbital mechanics 1. So there's a lot of some prerequisites in some courses, but otherwise the selection is up to you. Typically, the students begin with the required courses. This is the reason why these courses are required. These are the key courses in the space engineering area. So you will be much better off for when you first go through the required courses and then plunge into the specialized courses. Can you waive a required course? Yes, as I said, if we will never ask you to repeat the coursework that you had prior. We don't want you to waste time. There are so many opportunities to take very wonderful specialized courses, so this we will waive it. Technical electives from other departments. The answer is yes, of course. There may be very rarely we just restrict a little bit when students, for example, want to get in like in a management type courses, and then it's better for a student actually to consider switching a major to the industrial system engineering, for example. But otherwise, just from any science and engineering department in the university, legitimate graduate courses, we welcome you to expand your horizons and meet in the best way your educational objectives. So our degree also offers a pathway for students to get to leading system engineering positions in the companies. And if you are coming again from areas other than aerospace with a bachelor's degree from EE or mechanical engineering, and a number of such students, they grow in the space industry, but they cannot go further along the technical ladder, technical leadership ladder. They need more space education. They come to us. So we have a number of students who already have master's degrees actually in electrical engineering and mechanical. They come to us because it offers a way for them to pass to grow further. Now, attending classes on campus by distance students. So whenever, say, business trip brings a distance student to the Los Angeles area, you're just always welcome to come to the classes live, and we welcome that. It's the opportunity to meet an instructor, to chat, and to discuss whatever interests you may have. Now, difference between program in astronautical and aerospace engineering, it's a very frequent question. So we don't have time to go into the detail. I would refer you to one of those papers that I mentioned that can be downloaded as a PDF. But basically, in a few words, traditional aerospace departments, they continue to be focused on aeronautical part of the curriculum. And this is a historical reason, because the departments were built to support aviation industry in 1930s, 40s, and 50s. And in academia, to change the direction of the department is very not easy. It requires a lot of time. So the traditional aerospace departments, again, they did not provide as much space coursework as they could or should. So we established a separate department. And as you saw from the numbers growth of the awarded degrees, we are providing a valuable service with a valuable degree. So we are very successful in this respect. And this is also this industry interest that is mentioned is an indication that we have online students growing number. It's indication that industry is interested in what we are doing. It's a value for the industry. The next slide, please. And this is the last slide on my part. So we have a student advisor, Luis Ceballos. So he's very well qualified. Any questions for the applying directly to our program? So you always are very welcome to contact me. But please try to direct more administrative questions, say the deadline and the paperwork, this and that, to Luis rather than to me, because I may not know the answers. I know how to get to the moon and back, but I may not be that proficient in the paperwork. So, but on all academic questions, the coursework selections, focus this on that. So please feel free to contact me directly. Megan's also contact information is here. So also for the limited enrollment, she would be your point of contact to direct you to the right place. And I think this is all on my side.
So much, Professor Gretman. We have received some questions, so I'm hoping I can send a couple your way. One of the questions is, what career options would require a PhD versus a master's degree within this field?
It is a good question. If you want to pursue a career in industry, in a space industry, the most important degree is the Master of Science degree. PhD is needed, of course, but not that much, not that essential. However, to pursue a career in the academia, in the universities, a PhD is a must. And the PhD is also very helpful for pursuing careers in the government centers. For example, NASA centers like NASA Goddard, NASA Marshall, JPL. Although Master of Science is also very valuable there. In industry, it's primarily Master of Science degree. In academia, it's PhD. Now, I also want to mention that Master of Science degree is absolute must. There's a notion or a concept of the so-called terminal degree. 40 years ago, say 1960s or 1970s, one could join, say, a big aerospace and defense company as a Bachelor of Science engineer and have a rewarding career, technical career. I'm not talking about management where MBAs are needed, but to have a rewarding and full career, technical career as an engineer with a Bachelor of Science degree. Not anymore. Today, it is a Master of Science degree. So when you come with a Bachelor of Science degree, you will have to have at a certain moment of your career, but the earlier the better, to get the master's degree to be successful in the industry. Can't hear you.
Sorry about that, didn't unmute myself. Yep, okay. So if you choose to not do the thesis option, does that mean you would maybe disqualify yourself from pursuing a PhD? So I think the question really is, if you're looking to do a PhD, should you really consider doing a thesis option?
A short answer is yes. So doing a thesis, master's thesis, is important from 2 points of view. One point of view is it's a small research project, and by doing this, a student would try to do research rather than just attending a class and learning things, doing homework and exams. And by doing research, a student may actually come to a conclusion that I hated research. I don't want to do that. So this may not, to determine that this may not be the right path, not where the passion of this particular student is. So or alternatively, to feel that this is a fantastic experience, you want to do it more, you really want to be in research, so and you want to go towards PhD. The second importance, so it will help you to, doing a Master of Science thesis will help you to determine whether you are really passionate for research. The second thing is doing such a research would build up your resume for application to a PhD program, because this will be a demonstration of your ability. And if when you apply to a PhD program, and again, we're getting these applications, as you may imagine, dozens and dozens coming to our program. When we evaluate, we look at the students' aptitudes and their promise in research. And obviously, if you've done the Master of Science thesis, and we can look at, say, the results, perhaps a publication or a conference presentation coming out of that, it would be a tremendous addition to your application towards a PhD. So if your long-term goal is a PhD, then Master of Science thesis would be important. But I also want to warn you that you don't have to have a Master of Science degree in order to pursue a PhD. Majority of the students pursuing PhD that come straight after the Bachelor of Science with the Bachelor of Science degree and go straight to the PhD program. But there's a fraction of the students who got Master of Science first and then they applied to PhD programs.
Thank you. The next question is regarding the application. Two of the aspects of the application that that are required are the personal statement and a resume. The question here is, if the applicant is applying to both the master's and the graduate certificate in astronautical engineering, should they provide two different personal statements, or is the same personal statement okay to provide for both applications?
So this is one of those things that I mentioned, that I know how to get to the moon and back, but this is more an administrative type question. If I'm not mistaken, one cannot apply to two different degrees. It must be application.
You can apply to both. In one application, you can apply to two different programs. So they can go ahead. You will be required to submit a personal statement for both programs. Really, it's up to you. We do ask that you tailor the application to your personal statement to the degree program that you're applying to, because in this case, you're looking, you maybe can't decide between the master's graduate certificate. Then you may just have to tailor that personal statement slightly based on the graduate certificate versus the master's. But yes, you can go ahead and apply to both those programs.
I have a comment. Just a second, Megan. I have a comment on that. One of the ways to proceed. So one of the reasons that we established a graduate certificate a long time ago was the following. There are potential students who work in industry, and they feel uncomfortable to get back to apply to the Master of Science degree because maybe their mathematics is already too rusty and they forgot almost everything that they learned in their during their Bachelor of Science studies years. So they can start with the graduate certificate, and then after achieving this certificate, or on the way to achieving the certificate, they can apply to when they feel that they have enough interest and desire and ability to continue towards master's degree, they can then apply to the Masters of Science degree, and whatever the courses that they took towards certificate would be counted towards the Master of Science degree. This was actually original motivation for establishing graduate certificate. One of the motivations, there are several, but one of them was to open a pathway for students from industry who are not sure whether whether Master of Science perhaps too much for them, but after they take one or two courses or three courses towards the certificate, they suddenly realize, I can do it, and then they can get to the Master of Science degree. This is another option.
Great, thank you for clarifying that, Professor Grutman. So we'll finish the Q&A here with this final question, which is pretty specific to the courses. So the question is, does the spacecraft attitude control course cover both linear and nonlinear control system design?
The answer is not certain, because it's very often the mix depends on a particular instructor that teaches. So if there's a real interest about this particular course, the best thing is to send the email and I will connect with the instructor directly and you will get the unvarnished, accurate information on that. But typically there would be attached all various linear and nonlinear components will be touched upon, but it what mix again, it depends on the instructor and on other demands. So but the best thing is just to contact me directly. I will connect with the right instructor and you will get the right information.
Okay. All right, well, I think that's a great way to end the session today. Thank you, Professor Grutman, for taking the time today to share information about the MS in Astronautical Engineering and answering all these wonderful questions that came in. And thank you to everyone that attended the session today. We really appreciate all of you taking time out of your busy schedules to join us to learn a little bit more about our programs. Now, I just want to remind you that there is still time to apply for fall 2021. So if you have any questions, you can contact us directly for additional details. I believe I have, yes. So for general on-campus prospective student inquiries, you can email us at the address provided. For those interested in the online program, you can email that address. Either way, we're always happy to help. So no matter where you send your email, someone's going to give you a hand. So again, thank you all for joining us. And Professor Grutman, thank you again.
Thank you.